Okay, hello there guys, welcome back to another video tutorial about developing a game using LibGDX. So in the previous video tutorials we managed to create multiple stage files, and also we managed to instruct the game to load a stage after another. So this is the first stage finished, or let's say instead of stage it is a wave, so this is the second wave and so on. Now what are we gonna work on today is just adding the collision detection. So we need to identify if our spaceship sprite is colliding with an enemy. Okay, now before I start with that, let me explain how we are gonna do that. There are many possible ways to do it. Okay, so let us assume, let me put a box over here, right, and let me add some text. This is gonna be x1, oops, gonna be x1, okay, and there's gonna be x2. Okay, and the reason I am doing this is because I want to explain to you how this type of condition is working. Right, so no full, and I click here and we group this together. Okay, so we have this is let's say the box representing our spaceship, and let us create another one for the enemy, but we are gonna color this one this color. Okay, maybe red, so that it's like the enemy. So what kind of checks do we need to know? Well, there are many ways to identify collision. However, we are going to use the simplest possible one, which is detecting when two sprites collide, detecting if two boxes are are intersecting with each other. So let's have a look here. There are three cases. Sorry, there are three cases for this. The first case is that if you have a look here, you find that there is x1 and x2, and both x1 and x2 comes in terms of x-axis. Let me draw the x-axis here. Okay, so this line represents the x-axis. So your spaceship is here, this is the enemy. So your spaceship x-axis are before the x1, both of them. So obviously we don't need to check the y coordinates. Your spaceship is before the enemy, so there is no collision. Now there's another case. Your spaceship, both x1 and x2 are greater than x2 for the enemy, which means that your spaceship lies after the enemy. Okay, so these two cases means that your spaceship is not colliding. However, the other means it is colliding, right? So if you make this check here and this check here, and neither of them is true, this means that your spaceship either could be here, could be here, and if your spaceship is a little bit smaller than the enemy, so it could be, you know, between these two. Okay, it is very simple. Now after you do a check on the axis, you will have to do the same check on the y-axis as well. Okay, so if the check against the x-axis for your spaceship and the enemy, and the check for your on the y-axis for your spaceship and the enemy, both gives you a collision state, or, you know, intersection state, then there is actually a collision. We assume there is a collision like here, 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 or whatever. Okay, it's very simple. So we check if your spaceship is being here. If it's not, check if it's here. If it is not, then it is intersecting in terms of x-axis, but it could be here, 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 maybe here, here, here. So we finished checking the x. Now we check the y. So we'll do the same thing. We check if the y is here or here. Okay, so if it's neither here nor here for your spaceship, then it is colliding. Okay, so I hope this is obvious. So now let us see how we can do that in code. So if we go to the sprite class, we are gonna create a collision class. A collision method. Okay. However, we are gonna make this static. So public static boolean are sprites colliding. Okay, so here I'm gonna pass a sprite object A and a sprite object B. Okay, so the first step is that we have x and y. However, from the x and y, what we need to get is the x1, y1, and x2, y2 for each sprite. Okay, so what we are gonna do is the following. We're gonna say identify x1, y1, x2, y2 for the first sprite. So here we have float ax1 followed by ax2, ay1, ay2. Now ax1 equals a dot x. Now the x coordinates represent the center of your sprite, so we need to subtract half the width. So if we go back here, our x represent the middle part here, so we need to subtract, you know, half the width to get to x1, if that makes sense to you guys. Anyway, so we subtract a dot maybe I need to create a method for getting the width, right? Because I didn't set it here, so maybe I'll add them as members, and you know, so I'll just add them public public float width semicolon public float height. Okay, so we have the sprite width and height, and I'm gonna update the other sprites. When they load or initialize, they will fill these. So we assume for now that these are there and we are going to use them. So we subtract width a dot width divided by 2. Okay, semicolon. Now we have ax2 equals a dot x plus a dot width divided by 2. That's fine. Now the same thing, ay1 equal a dot y minus a dot height divided by 2, and ay2 equals a dot y plus a dot height divided by 2. Very simple, very straightforward. Okay, so we finished finding these values for the first sprite. Now we find the same thing for the second sprite. For the second. Now instead of A, I'm gonna call these variables B. Right? Okay. So here this is gonna be what? So it's gonna be B, 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 sprite 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 B. Okay, so now perform a check against the x-axis. Perform the check, that's it. Now let's check first. Now we check if ax1 is it smaller than bx1 and ax2 is also smaller than bx2. Okay, at that point return false, because our box or spaceship lies before the enemy. Sorry, this one should be bx1. So let me show you this. Oh, oops, sorry, click. So here this represent let me call this is ax1. Let me, okay, this is gonna be ax2. I'm taking some time here because I want you to understand how this works. Okay, because we are also gonna optimize this. bx1, this is gonna be bx2. Okay, so here the first case, your spaceship is here, so ax1 is smaller than bx1 and ax2 is smaller than bx2. Now we could optimize this further. If ax2 is smaller than bx1, then by default ax1 is smaller, so we just need to make only one check. So instead of this, we just say if ax2 is smaller than bx1, return false. This is the first case. Now the second case could be is that ax1 is greater than bx2. So I would say ax1 is greater than bx2. So you finished two cases, right? Because if this one is greater than this one is also greater than this one. So we don't need to make 4 checks. Instead, we create 2 checks, and now we detected if our box, if the box lies here or the box lies here. This means there's no collision. Also, what if the box is intersecting, right? What that means, we need to make a check, right? Before that, let me check something quickly. So let's say here, wait a second, let's assume this one's a little bit bigger. So let me see. So if ax1 this is not a smaller, and ax1 should be x2. Okay, that's fine. Okay. Anyway, so let's check the other case, the case for the y-axis. So we have if ay2 is smaller than by1. So or ay2 is smaller than by1, or ay1 is greater than by2. Okay, so you might be wondering, sorry, this needs to be if ay2 is smaller, this needs to be a smaller than, right, and this needs to be greater than. Okay, so in case you get confused, how did I do these conditions? I just came back to these, and based on them I just make checks. Okay, that's all. So these 4 conditions are telling me if the boxes are intersecting with each other. Otherwise, this means that these boxes are not intersecting at all. So sorry, these checks are telling me if the boxes are not intersecting. So if anyone applies, we return false. otherwise we return true. Okay, so let me just say else. So this is the first form of collision detection. Very straightforward, very easy. Okay, just one line for conditions to be met, and that's it. Now let's go to our player sprite. Where is that? We have onboard player spaceship. So in the initializer here, we would say this dot width equals spaceship texture get region width. Okay, very simple. This dot height, because we added the width and height to the sprite, spaceship texture get height. Okay, so we got these. So I'm gonna copy this. Let's go to three-headed spaceship. There you go. Very straightforward. And again, we will add this here. So instead of this, this is gonna be spaceship texture. Yeah, this is it. Now let's go to the part where we make some checks in the game, right? So let's go to G01 game, okay, which is our game class. And so here we are updating variables and rendering stuff, blah blah blah, right? Now checking if sprites to be enabled, update user input, the player and enemies, update user input, the players and enemies. Okay, I'm gonna update them here. Okay, before I render stuff here, I will just add checking collision between the player and enemy. Okay, spelling no collision. Yeah, I'm misspelling the word. All right, word. Yeah, I'll have to improve my English later on, maybe later. Anyway, so all I have to do is this simple thing. For int I equals 0 and I smaller than enemy stage enemies dot size and I plus a plus. Now if sprite dot are sprites colliding, you remember that this method is static, so we just use the class name followed by the method name, and I need to pass player spaceship followed by stage enemies dot get I. And before I do that, I forget to add some very important check here, which is wait a second, what was I made a mistake here, right? Yeah, it's a player, not player spaceship. Player, the player object. Yeah, so if stage enemies dot get of I dot enabled. Okay, so if the sprite is being enabled, at that very point I'm gonna check if the sprite is colliding with the player. So if the sprite is colliding with the player, I need to do something to indicate that that you you collided. So for now I'm gonna just say through a new exception you got hit, right? Instead of throwing an exception, this method is not supposed to have exceptions, so maybe I will just say stage equal 4 semicolon and stage enemies dot clear and I would just say break. Yeah, so if I hit any of the enemies, all of the enemies are gonna disappear. Okay, this is what I did here. I just say that I want to go to stage 4 and I want to clear everything and break in order to exit this loop. So let's see if this works well. Okay. So for now, this is the first wave. I want to hit this one. Okay, so they all disappeared. Let me stop this. Let me run. But this time, I'll make my spaceship pass between the enemies. Okay, so I should still get waves. So let me be here. Okay, you see, they didn't disappear right away. There's the second wave. I'll try to be as close as possible. You can see, no problem, it worked. Now, the last wave, I will, just touch it at the very last minute. Go. Okay, so our collision detection seems to be working fine, right? Very nice. Now, what should we do? Basically, we shouldn't stop the waves. Maybe we make our spaceship get destroyed, or maybe if your spaceship has some, number of lives, these lives need to be reduced by 1, and so on. And if your lives goes to 0, you get a game over. Now we could do that now, or maybe I think we should do this later on. Don't want this tutorial to be very long like the previous ones. So I guess that will be all. So as you can see, we implemented a very simple collision detection technique only for comparisons, and you can detect if your spaceship is colliding with the enemy. There is even an even simpler one. We could have used that, which is you calculate the distance between the center of each, and if the distance is less than specific value, for example something like this, less than the width of the box of the width of the box, at that point you would say, well, there is a collision between these two guys. So yeah, that is another way to find collision detection. Maybe in the future we even use a more advanced one based on pixels in order to get a even better results. Okay, so that will be all for today, and hopefully I'll be seeing you tomorrow, and we will see how we can create multiple lives for your spaceship, maybe give it some hit points, and specify the enemy power, how much damage that the enemy could make to your spaceship. And if we have enough time also, we might add a game over, start working with game over screen and projector things and stuff like that. Yeah, so thank you, have a nice day, bye bye.